Have you ever stopped to think about the invisible digital battlefront that, keeps our lights on, our water running, and our factories actually producing things? Well, every single day, there's a silent war being waged over the control systems that power our modern world. So let's dive into what happened on that front line this past January. Now, all the information we're about to go through, it's not just speculation. We're breaking down the key findings from the official monthly report on industrial control system security for January. This gives us a really direct, data-driven look into the threats and trends shaping the security of our most critical infrastructure. And that really brings up a huge question, right? From the power grid to the trains you might take, our reliance on these connected industrial systems is, well, it's absolute. So let's explore just how secure they are and see what the latest intelligence is telling us. First up, let's start with the big picture, policy. In January, it looks like governments around the world really went on the defensive. They started making some pretty significant moves to fortify their digital borders and protect their most vital national assets from cyber threats. China, for instance, made a major strategic push. They announced plans to weave artificial intelligence deeper into their manufacturing and to really bolster their industrial internet. But what's really interesting here is the focus on emerging tech. We're seeing specific new rules to protect new vulnerabilities, like electric vehicle charging stations and, get this, all the data flowing from connected cars. You gotta remember, every new point of connection is a new potential door for an attacker. But policy is one thing. The reality on the ground is something else entirely. So now, let's shift from government plans to the actual cyber attacks that made headlines in January, where digital breaches had some very, very real-world consequences. Over in Europe, we saw two totally different kinds of attacks that really tell a story. In Romania, the Oltenia energy complex got hit by a ransomware group called Gentlemen. This was a financially motivated attack, plain and simple, and it disrupted their IT systems. But then you look at Poland, where the national railway infrastructure faced repeated disruptions. And these are believed to be from state-sponsored actors, a really clear example of cyber warfare being used for geopolitical goals, specifically targeting services allied with Ukraine. So who are the actual people behind these kinds of attacks? Well, the report zooms in on one group in particular, Transparent Tribe, also known as APT-36. This is a classic cyber espionage operation. Their primary targets are Indian government and military organizations. Their goal isn't just chaos or disruption, it's information. They want secrets. So how do they pull it off? Their main weapon is something called a RAT, which stands for Remote Access Trojan, and it's often delivered with a surprisingly simple trick: getting someone to open a malicious PDF or a link file. Once that file is opened, that's it. The malware installs, and the RAT gives Transparent Tribe complete control over the victim's machine. They can steal files, spy on everything, and do it all completely undetected. Now, shifting our focus to the conflict in Ukraine, the report identified a particularly nasty malware toolset called Pluggy Ape. This was reportedly deployed by a Russian advanced persistent threat group directly against the Ukrainian Defense Forces. And this is where we see the intent behind some of these attacks get really serious. See, Pluggy Ape isn't just for spying. It contains a purely destructive component called Void Blitz. This is what's known as a wiper, and its only job is to permanently erase data and make computer systems totally useless. This isn't about theft, it's about digital demolition. So with all this stuff going on, policies, attacks, how do we know what attackers are really looking for? That's where the data comes in. Researchers use what are called honeypots. Think of them as decoy systems, intentionally left vulnerable to attract attackers, just so we can see which doors they're trying to open most often. And the data from these honeypots for January, well, it reveals a fascinating trend. As you can see right here on the chart, while attacks on most protocols kind of stayed steady or even went down, scans for one in particular, the Siemens S7 protocol, absolutely skyrocketed. This is a huge flare in the sky, a clear signal that attackers are actively hunting for vulnerabilities in these specific systems. Okay, so what is Siemens S7? It's basically a communication language used by programmable logic controllers, or PLCs. You can think of PLCs as the small, tough little computers that automate everything from assembly lines to power grids. So if you can gain access to this protocol, you can gain control of the actual physical machinery. Now, zooming in on the Russia-Ukraine conflict zone, the data points to different vulnerabilities. Honeypots in this region showed a really high number of exposed devices using some older, but still critical, protocols like Modbus and XMPP. So what do these actually do? Well, Modbus is a total workhorse. It's one of the most common languages for communication between industrial electronics. And XMPP is used for real-time communication, kind of like instant messaging. Leaving either of these exposed opens a direct line for attackers right into both industrial controls and communication channels. Okay, so let's connect all the dots here. We've seen the policies governments are making, the real-world attacks, and the raw data. What does it all mean when you put it together? The key takeaway from January's report is this. There's a really dangerous gap opening up between the policies being written and the sophisticated, fast-moving threats that are actually happening. While governments are building these big digital walls, attackers are already finding new ways to tunnel underneath them, turning digital vulnerabilities into very real physical risks. And that leaves us with a critical, kind of scary question for the future. As we connect everything, our cars, our cities, our factories, to the internet, are we building stronger, more resilient systems? Or are we accidentally engineering a brand new, more complex kind of fragility into the very foundation of our world? You know, if you found this breakdown of industrial security valuable, it would be a huge help if you hit that like button and subscribe for more explainers just like this one. Your support is what helps us dive deep into these complex topics. Thanks for watching.